Yep. I'm sharing successfully.
Yeah, we can see your slide and you can see yourself and hear you.
Great. So I'm Matthew McPherrin. I work in the information security team at Square. And it's my team that's rolling out SPIFFE and SPIRE at Square. So today what I'm going to talk about is how we went from our prototypes to an operational production quality SPIRE that we were happy to rely on. So I'll start with a little bit of background for just framing the discussion. Square is a multi-cloud, hybrid cloud environment. We've got data centers running on bare metal, running homegrown deploy systems and provisioning systems, some of which will be Kubernetes in the future. We've got AWS. The compute in AWS is primarily Kubernetes and serverless, as well as the other AWS data products that aren't compute. We've also got some Google Cloud running GKE, primarily to support some data systems like Bigtable and Spanner that are unique to Google Cloud. Different business units tend to run distinct Kubernetes clusters, and we have shared Envoy service mesh between all of those, between the Kubernetes, between the Lambdas, and we use SPIFFE identity on that service mesh. We have multiple different trust domains partitioned up by a bunch of different things. So production, staging, development environments get different trust domains per environment. The different infrastructures have different trust domains. The data centers have their Spire cluster. The different Kubernetes clusters have trust domains, as well as our Lambda usage. And we have some cases where we have them broken up by business. So we have a bunch of lines of business between our seller business, which is payments and that kind of thing, and Cash App, which is more consumer focused and have some different constraints on infrastructure and compliance. Some of these trust domains are using Spire. Some of them are using homegrown code that's primarily for Lambdas, where there's not really good serverless support in Spire yet. And there's potentially some interest in using Istio and its SPIFFE support in the future. So Spire is a very critical part underlying all of our infrastructure, and it's ultimately very complicated. It's still a young project, and we have to learn about it. So I want to talk about all the different things that we're going to go through, and the first of that is how do we architect to have a reliable Spire instance. So I've got a quick diagram here that outlines kind of a lot of the constraints we're thinking about. I'm going to focus on our data centers because that's where we've been running Spire the longest, and there's some additional challenges that don't apply to cloud environments, like having to run your own databases and handle server failures and that sort of thing in a way that is different in the cloud. So the server uses a relatively small amount of compute, so we want to ensure we have n+2 redundancy. So if one Spire server can handle all of the load, then we make sure we have at least 3 pods. That allows one to fail and another one to be down during a deploy or something. As well, we have the agents contact only the Spire servers in their data centers to avoid cascade failures between regions. I'll talk a little bit more of that later. We use a shared database between our different data center regions, and one of which is kind of anointed as the global write location. This is primarily because of the way that our service scheduling works right now, is that scheduling happens usually in one data center, so we want all the writes to go there, though it could happen in multiple regions. We have a pair of replicas in each data center, an A and a B replica. That's used for maintenance, so applications are only ever accessing one, we'll call it a side, A or B at a time. And then we have replication to other regions for disaster recovery and potentially for read offload. Read offload to a read replica is supported in Spire, but we aren't using it yet. We haven't necessarily had a need to, and it would is another set of failures we haven't quite tested yet. A managed product like AWS RDS with multi-AZ databases would kind of provide that same AB stuff for you, maybe, but we have to do it ourselves because we're running on our own data centers. So that sounds pretty great on paper, but we want to make sure that this actually works. So my team ran through a bunch of scenarios, testing them in conjunction with our database teams and our traffic teams, and validated that Spire worked properly in all these cases, and it did. So, that's great. We, had a few fixes that we sent upstream, mostly in making sure error messages and some error handling was good, but overall, it did pass all of these tests we're going to talk about. The first of these is database failures. The database is in many ways the biggest single point of failure. And if we lose the primary rateable database, it dies. Maybe the hardware died, maybe MySQL crashed, maybe it lost power, maybe it lost the network. We want to make sure we survive this. So our goal here is that, we know the Spire server is going to fail. It's probably going to start returning errors to all of its API endpoints. We don't want it to crash, but we want it to be up and unhealthy. The remote, Spire servers that are using a read replica should probably continue to do some reads, but we haven't, again, as I mentioned, tested that yet in our environment. Now, we know the Spire server is going to go unhealthy. What we want is to make sure that the Spire agents are unhealthy. So in this case, the database is failure. What we're testing is the agents. So the agents need to continue to serve the SVIDs that they've already retrieved from before the server went away. Workloads are registered at deploy time, and we use several hour SVIDs. In event of the database going down for an hour, it shouldn't impact our production traffic because the Spire agents are still serving those SVIDs, which haven't expired yet, to the workloads. Once that database fails and we do a failover, we use BGP for our databases. So we'll move the IP to a different database instance, which was formerly the replica. And then we need to make sure that the Spire server resumes operation once the new database is healthy again. And in particular, we want this to happen automatically. We don't have to go in and restart Spire or reset connections or something. We want to make sure that as soon as that new database comes up, that Spire resumes successfully. This is important since the database failure might be handled by an automation team, or actually this sort of flow. I mean, in the illustration, I illustrated a failover where R1A failed, maybe it crashed or whatever, and then we switched to B. But actually, we do this routinely as part of maintenance, because if we need to upgrade the version of MySQL, upgrade the underlying OS, or just move it to a new piece of hardware because the disks are filling, or we're doing generation upgrades of the hardware, we do this routinely as part of our operations, and we call that a success over instead of a failover, and it's a little bit more graceful. But we want to make sure that Spire handles that case. There's sort of another big database failure case, which is where we lose an entire region. In this case, the whole thing might fall down, and we have to start using the replica, which was formerly in a different data center. In this case, we can just assume that full region is dead, and if it's a big enough failure, we'll just power the whole thing off and make sure it doesn't come back up to life unexpectedly. And here we use this kind of database name, which is a global CNAME stored in DNS, and we flip that to the new master, as well as reconfiguring MySQL to allow writes and to stop replicating from the now dead primary writable that was before. In this case, the only kind of constraint we have here is that the Spire server should successfully switch to that new master, that it re-resolves DNS on database failure. And then once the old region comes back up again, someone uncuts the fiber or whatever has happened to it, we can have the old Spire server now use the new write database. So this has worked pretty well, and it's kind of expected given that Spire uses standard, robust libraries for MySQL that we kind of expected it to happen. So we'll talk about the second scenario, and this is kind of more getting into actual Spire specific stuff, is what if the server fails? So in this case, we run N+2 redundant servers, as I mentioned. So we should be able to handle any particular node failing. Maybe a single node dies, but there are some scenarios where everything could fail. Maybe a load balancer in front of it fails. Maybe an engineer botched a deploy, put a bad image out. And unlike the previous scenario where the server would start returning errors to the agent, that the API request would fail, in this case, the server is completely gone. Requests will start to time out, or DCP timeout, or gRPC timeout at some level of the stack. And again, we have the same constraint. We want the Spire agent to stay alive in this kind of stale state where it's serving the SVIDs that it already knows about, except that it won't get any new ones. And then, of course, at some point, the Spire servers will presumably come back. We'll fix the load balancer. We'll do whatever we did. And we want everything to return to healthy, and that new pods will distribute. In this diagram, in the previous one, I kind of illustrated that one region's or one data center's servers went away. Do we want to fail over the agents to the other ones? We don't want to do that automatically in our environment because we don't want to involve any risk to the second region. Perhaps the reason that the Spire servers crashed was because we rolled out new agents and they tickled some bad case in the server, and the servers crashed, and then everything fell over. So we don't want to put that risk on a second region. So we have no automation there, but actually there are some cases when we do need to do that, and when we have some runbooks for the situation. The primary concern we have is that Spire is this very fundamental piece of our infrastructure now, and actually the deploy system itself relies on using Spire to have the agent that runs on every node and finds out what Docker containers it should be running, uses SPIFFE to authenticate to the control plane. So if the Spire agent is down on a node, then we can't deploy new things. So if there's kind of a chicken and egg problem here. So we have this runbook that we have, and one of the things that I kind of want to mention is we did actually have to write a bunch of these tools ourselves to make sure that we can handle these cases, because this is such a low-lying component in our bare metal stack. If all of the pods are down everywhere, then we need to break out a really big runbook that involves probably a lot of SSH and running Docker commands as root to start things up, because the deploy system is going to be toast. We did that as an annual disaster recovery exercise in our staging environment, where we shut the whole data center off and turn it all back up again, and making sure that there's not this coupling between the Envoy service mesh, the Spire pods. We use an upstream CA, and if Spire uses Envoy to talk to its upstream CA, authenticated with SPIFFE. So there's a lot of low-level chicken and egg problems here that we had to make sure that we solved. Especially in this case where all of the servers are gone, and we want to make sure that we can come back to life. The third situation is when the Spire agent itself fails. On a single node, we don't care too much about that because all of our workloads tend to be redundant. But we should make sure that they work. There are cases where maybe a database, some data store is primarily on one host, and if it failed and lost all its connections, it would have to restart. So we want to test that case too. So the first case, and we mostly use Spire with Envoy as our service mesh. We want to make sure that if the Spire agent disappears for whatever reason, becomes a ghost, that Envoy continues to work successfully. So Envoy is using the secrets discovery protocol to get its SVIDs, and we want to make sure that in that potential failure, that Envoy continues to serve its traffic. It doesn't break any connections. New connections can still form, which in some ways is testing Envoy. It's also testing the secret discovery point. But this, again, as expected, continued to work. There's also testing the workload API clients. We've primarily tested using the Golang library, which we use for some of our integration testing, as well as some other tools, including command line tools, and our own project Ghost Tunnel, which is a proxy that we use in some cases instead of Envoy, because it's much simpler and has some different properties. It appears to also handle it properly, that the workload API going away doesn't interrupt any existing connections. And then, of course, once the Spire agent comes back up, we want everything to resume. And in our testing, this has all mostly worked out. The last failure scenario I want to talk about is kind of a more generic one, and that's when the client sees, no identity issued. And that can actually happen for a bunch of different reasons up the stack. The workload registrar is not working right. Writes aren't going through to the Spire server. The Spire server is just overloaded or behind in some way, or the deploy system has failed in some way. It's not calling the registration hooks. So what we really want to make sure here is that a rolling deploy doesn't continue. So you can imagine, you have a Kubernetes deployment, you update a container, it's going to shut down all the old pods after starting up a whole bunch of new ones. Well, if those new ones didn't come up with SVIDs, then we want to make sure that those old ones don't get shut down yet, because then your deploy will have just killed your system. So this is something we've done a bunch of interactive testing with, where we shut down Spire, we deploy some services, and we make sure that they didn't explode because Spire was down. We want to make sure that that deployment doesn't continue. The easiest way to do this in a Kubernetes or Kubernetes-like environment is to ensure that you have a status endpoint that doesn't return healthy until the workload has an SVID. And actually, the most foolproof way to do that is to require that the status endpoint serve an SVID, because if you need to have an SVID to return healthy, like implicitly in the protocol, then there's no way that an app developer can screw it up. So I just want to talk briefly about kind of how we monitored Spire during all of these exercises that we ran through. And again, how do we have confidence that it's working? So metrics are kind of the primary thing. These are like time series data points, tell you how long API endpoints are taking, which are succeeding, which are failing. This works out of the box really great in Spire. There's a bunch of common protocols supported. We've used both Prometheus and DogStatsD in various parts of our infrastructure. And I think there's going to be a talk later today where we'll hear more about that. One thing that we also like to do, and it's not really a documented feature in Spire because you actually do have to modify Spire to do it, but you can, I have 4 lines of code on screen here. You can have a custom main function which invokes Spire to run, and this works with the agent as well as the Spire. And because Spire uses the Logros logging library, which has customizable formatters and hooks, that allows us to use an outside package that has Square's preferred logging options for Logros to, in our build of Spire, provide logs in the way we want, both to our JSON formatted output with all the the details that we want, as well as warning and error level logs we send to Sentry.io, which is a system that allows us to aggregate metrics. And this page from the Logros wiki, there's a ton of these different hooks and formatters that you can use, and it wouldn't make sense to build these into Spire because there's just so many of them. A lot of them are custom, and you kind of have to compile time opt into them because of the way Logros works. It doesn't really have any runtime config. It's all compile time. And this lets us go from our logs, maybe we get outstream bundle, to these nicely aggregated and actionable warnings and errors in Sentry.io. And this is like a screenshot of the first time we got it to work. And you can see, this like some warning that, we had this upstream bundle config option set. And we can mark that resolved once we've fixed it. So it lets us track, what the state of our system is. And the other kind of thing I mentioned earlier is that we use observability around health checks to make sure that everything upstream, that when Spire is down, that other workloads don't. We have started integrating some health check infrastructure into Spire itself, but I think we could still do a bunch more things. And we think this is pretty important for having a rock solid integration. And I expect to see more work on there too. Just one last little section. I want to talk about the most common issues we ran into and how we recover from them. First is just make sure we have an incident runbook. There's a website here, outage.party, which I would say is Square's philosophy on how to handle incidents. Is you find out what changed and you undo it. And that means implicitly having the tools to undo any change. For registration entries, maybe you've got old data, maybe your broken registrar dumped a bad data in. Make sure you have the tooling to recreate your data. The Spire server entry create is maybe fine for development and testing, but it's not the kind of thing you want to have heated engineers using in an incident. And so we have some manual registration tooling to help with that. The other most common thing we run into now is an inspired agent SVID. This is kind of an intrinsic property of running bare metal, is that sometimes servers are down for a period of time. Maybe we have to unpower them for a day or two because maybe we're physically moving something or whatever. Or it accidentally happened. So we use join tokens, so we have to have tooling to automatically reprovision those servers. You could just wipe them, and if, say we're doing a rack move in the data center, we'll just wipe the whole rack of servers, move them somewhere else, and reprovision them. You don't always want to do that. Maybe you've got data on them or something. So having tools here is really key, and especially when we're rolling out Spire, we don't want to like reprovision servers every time we break it, because that would be annoying for everybody involved. The last thing we ran into is the corrupt agent state, which is much less common. Because the agent state on disk went sour for some reason. I made, I think, at least a couple pull requests, adding some fsyncs and improving local state. And again, we have a tool here where an on-call engineer can just point at a server and say, reprovision this from scratch, wipe all the local state, and redeploy it. I think that's all I've got. So if anyone has any questions, I can see if there's anything in the chat.
Yep. Thank you so much, Matt. I think there's a question that's saying, are there any plans to drive observations upstream into application monitoring platform? ServiceNow, AppD, Dynatrace, New Relic, Datadog?
In my opinion, the correct option for Spire here is to adopt the open telemetry specification, which is still kind of new, that has tracing and metrics as a standard way to integrate them into your application. Open telemetry came out of a merger of Open Census and Open, I forget what the other project name was, a bunch of things kind of pushed together as a standard way to instrument tracing, monitoring, logging into your application. You can do some of this today with the integration with Logris. So I said you have the custom loggers that you can provide. So that's something we've done in other applications, not in Spire yet, where you can provide a Logris hook to include application monitoring platforms in there. And we've used Datadog, so we've done that in a couple places. But I would like to see some great stuff, and I think there's going to be a talk later today about more metrics and telemetry stuff if you have more things you want to know.